We're in May.
The day, whatever, Mr.
The 10th.
Thank you.
You're welcome.
That's our Mother's Day.
Are you going?
Yeah.
But it's in the day.
Okay, ladies and gentlemen, in 3 minutes, I will show you the balanced equation. If you can't get a balanced equation done in 3 minutes, you need more practice. By the way, there are 3 products in this, and that's why I specifically tell you what the 3 products are in this reaction.
What's hydrochloric acid? I can't find it.
Well, you need to know how to name an acid. You're not going to find just hydrochloric acid on your periodic table. Sulfite, not sulfate. Good catch.
So then, like, it's sulfite. Does that change the what's like the back of here or no?
You don't even need the back of here there for this one.
Why?
Because it tells you what state everything is.
It just says sodium sulfite reacts with.
But it's giving you a molarity and a volume, which means it has to be a solution, which means it has to be aqueous.
Like if you didn't tell us. Wait, so this one's making 3 reactants?
Three products,
Three
not
products,
3.
sorry.
Yes.
Yeah, okay.
Yes. Follow the same rules on the back. Sulfate, sulfite, they have the same charge, so they should react similarly in water as well.
Is there 3 on both sides? No.
2 reactants, 3 products. What?
Oh, just refresh the page. It does that sometimes. I know mine does that too every once in a while.
Okay. So again, ladies and gentlemen, you're going to be taking a test in basically a week. And you're going to have to write 4 balanced equations for it. If it's taking you longer than 3 to 4 minutes to do an equation, you're probably not going to have time to finish all of the problems. So then you better think about, okay, which problems am I going to do to get the most points for if I can't finish all of them? Okay? So here we go, ladies and gentlemen. This would be our balanced equation for this particular reaction. Na2SO3, aqueous. Aqueous because we have a molarity and a volume. You cannot have a molarity unless you are aqueous. Okay? Reacts with hydrochloric acid. Now again, people are asking, well, how do you do acid? I've been over acids with you. They're in your notes from Unit 3 if you need to. Okay? But again, if you need extra help with something, you need to come and see me. I'll go over how to write acids with you. But again, we did that a few days ago as well. The 3 products, aqueous sodium chloride, NaCl, aqueous, liquid water, H2O with an L after it, and sulfur dioxide gas, SO2 with a G after it, ladies and gentlemen. Okay? So now you have your balanced chemical equation. A 2 goes here to balance off the 2 hydrogens on this side, and a 2 goes here to balance off the 2 chlorines and 2 sodiums on this side. Everything else is balanced. This is one, though, where that little trick that I've been showing you lately about leaving like the SO3 together, you could not do that here because it doesn't appear the exact same on the other side. So you would have to break the sulfur and the oxygen up. Okay? Yes, Kiana.
Is this a limiting reactant one?
Yes, it is.
Okay.
So that's why you've got to identify what the limiting reactant is.
Oh.
It's that last sentence.
I
Sorry.
didn't finish reading it.
Nope,
sorry.
that's fine. That's fine. Here's what I will tell you. Other than your quiz tomorrow, the problems that you get from now on will pretty much all be limiting reactant ones. Okay?
You said that wasn't
On
on the test.
the test or the quiz?
Oh.
This is going to be on the test. Yes. Yes. It's not going to be on your quiz tomorrow. No. So, but it will be on your test. Okay? So now, ladies and gentlemen, identify what you're given. Identify what you're looking for. And solve the problem. Again, you need to do 2 equations because you need to figure out how much product you could create from this reactant, and then you need to figure out how much product you would create from this reactant. And by the way, this problem involves every single way I can give you information or ask you to put it into a final answer. It involves all 3. You've got a molarity and a volume here. You've got a mass here, and I'm asking you to find the volume of a gas that you create. This is everything. Go to work.
Are we using a PV equals nRT formula?
Well, do you need to find the volume of a gas at non-standard conditions?
Yeah.
Then yes, you have to. Yep. KP.
To find the moles of the first one of the 145
Yep.
milliliters.
Yep.
We would convert that into liters.
Yep.
And then would we multiply that by the 0.9?
Yes.
Okay.
We have been taking the volume times the molarity because that's moles over liters. So when you take volume times moles over liters, the liters will cancel out and you will be left with moles. The 10.6 grams, you should be able to handle. We've been doing grams to moles for, I don't know, 8 weeks, 7 weeks, somewhere in there. If you have questions, ladies and gentlemen, call me over. I'll be happy to come over and give you assistance.
I need help.
Okay.
Is this right? It just doesn't make sense that's the exact same thing for both.
It's not the exact same thing for both.
Okay, so then what did I do wrong?
Well, where's your calculation for the second one?
No, I mean like the moles for this is the same thing.
That should be because this is a 1-to-1 ratio. So however many moles of that you started with, when your ratio is a 1-to-1, that's how many moles of that product you want.
Oh, okay.
Because it's a 1-to-1 ratio.
Yeah. Okay.
So that, not unusual, not at all. Okay? Yes.
I did the best that I could, but I know I'm missing something. I'm missing the 10.6 grams. I don't know what.
You need to do a second calculation for the other reactant with that
I
10.6
just
grams.
solved it normally, so I got the volume.
Okay, well, here's the thing. Now consider the second problem with the 10.6 grams of HCl. Solve it, and then the main thing is just tell me it only produces, it only can make a smaller amount.
Using the molarity that it gives you, and then you have to do the same thing with the 10.6 grams. So just do that, do those separate, like see, I did the first one right here, and then do the second one separately. And get them
So
both
far, you are.
into
Keep going.
moles, doing.
What's the second step?
Like
First
into
step is to
mole,
take
and
what
then
you're
you
given
want
and
to
get
do
it into
molarity
moles.
too.
That's what you're doing here. What's our
Yeah,
second
do that
step
to both.
always? The ratio step, yes. Have some confidence. You got this.
What do you mean?
You got
How
this.
many per liters?
So you put those in here and then.
Yes.
So just.
So literally everybody in their brother is sick.
Multiply.
Lucy's sick, Phoebe's sick,
No.
Joe's living here today, so she's sick.
Right, sick.
But there is no formula where you take grams times molarity.
Sonia's sick.
She is?
Yeah, no idea.
You said you had a track meet today, right?
James
Yeah,
is
so I
sick.
don't know
You
where
can't
Cynthia
use
is,
this
unless she's
as
has an
because
excuse.
this is
I was
not,
gonna say, yeah,
she's
she's
running.
running excuse, but
that's not,
Yeah.
the only
I know
time
for
you
sure
can
she's
use
the only
it on
one
a
right
quiz
now.
is something as a gas.
yeah.
It's a gas load. You can't use it on something that is aqueous, you cannot use it on something that is a liquid. You can only use it on a gas. So you are gonna use P equals nRT in this problem, but at the end,
So that's the
Figure out-
molarity.
So take this
You wanna get the milliliter into liters.
volume and molarity and get it into moles. First step always, take what you're getting, get it into
Moles,
moles.
or whatever, it's about to break the school record, the 0.957. Because that's
Two pages
literally
broke the school record.
so much is multiplied it by,
Jason's so good.
once you switch the milliliters and liters, multiply by that, and then it'll give you how
You
many
know what
moles
was
it
saying?
is in that amount.
He was saying he doesn't have faith.
Am I doing this right?
Any
So
athletic
I'm doing the
GoPro
second
except
one.
for
Yeah.
literally any of
He's
them.
literally right.
No.
So because the molar ratio, we do that once we get it into molar.
See, that's what I thought, but because it's a
Yeah.
So in the
hydro,
second part,
it's
you should do the
Because then
same.
it'll switch it from.
You're always going to the same product.
Right, then yeah. it would be the-
The only difference is you have a different reactant that's going to that product,
I know.
right? Otherwise,
That's why I
if you,
write it
if
down.
you compared it to two different things, there's no way you could
ratio.
know which one
So for
is
that one,
limiting
yeah, no,
because
we're
you're not
gonna do
comparing the
is
same
we're going
product.
from the Na2SO3 into SO2.
Is that what?
Where to put what? So this is where the molar ratio comes in. So you're going for the
Okay.
first one.
10.6.
So leave the 10.6
What are we
for
doing in
now.
that problem?
Because we're still only using the first reactant. We're still only
Moles
I want to.
or
I'm
Moles,
scared.
you take
Gonna get
or over the
We don't have
moles that
grams.
were given.
That's grams, okay, that's grams of hydrochloric acid, all you do is convert
It's
that
not
to moles.
So that's what
It's literally almost gone.
How do we get from
So for
grams to
that,
the
that's
substance
SO2.
into moles?
And then you do the HCl6, SO2, or whatever
So
one is
that's so
smaller.
that we can solve for how many
That's your-
layers using the P SNRT formula.
Equal
I mean,
to,
you can put it into liters right away, but like,
formula mass. 1 mole over
I just
formula
have to
mass,
put it in
we've
the.
been doing that since unit 5. What?
I just wanna know if I did it right.
No, of the one substance that the 10.6 grams represents of the hydrochloric acid.
Yeah, for the first one, it's fine.
What do you mean you gotta make that up?
Okay.
Never mind.
So you grab the molar ratio.
For the next one, it gives us a 10.6 grams of hydrochloric acid, right?
And then.
So then what you have to do is you have to get it
Hey,
in there
hey,
using the formula.
Let me know.
That's what we've been doing.
Okay, but
Oh, I just.
you're doing some extra stuff that you don't
No
have to do.
formula mass, like when you
Well,
look,
I thought.
because the formula for hydrochloric acid is
I didn't do
HCl.
that third
So then
step.
you would
Oh,
do,
You don't have to.
I
You
don't.
that's
can
a
stop
separate step
after this
from-
step, that's what we
And
taught
then
you
what
yesterday, and just compare the moles, because if you're gonna have a smaller amount of moles, guess what? You're taking it times the same mass here, you're gonna have a smaller amount of mass.
Okay.
If you
Yeah,
put it into P
zero.
equals nRT, a smaller amount of moles is gonna equal a smaller volume as well.
Do I need to ask you to present our
You did this, no, you don't, why? Because this is the smaller one.
Anyways.
You take the smaller one and you put it in here, but what I'm saying is if you did this same calculation with this larger amount,
Yeah.
you're gonna get a larger amount here. You can only always make the smaller amount.
Okay, and how do I do the limiting reaction?
Well, which one do you run out of? Which one
Sorry?
created the smaller amount?
So the first one, well, I forgot the formula for limiting reactions.
There isn't a formula. What it is you look and you compare how many moles of product you make. Whichever one makes the least amount, you go back and you say the one
Don't
that,
you need to divide
So
the
good.
grams though?
I used to have
So
to
over here.
no, that's at the end of the problem. That's
That's
not being asked to do it, you're not being asked to do that in this.
I think it's
Oh,
just so
so
far.
far.
You're not, that's what I'm saying.
So I
There
just-
is no percent, that is a percent yield calculation, we're not doing that.
So I just-
Well, you
That
still
doesn't
have
have
not
to
yet
be-
identified the limiting reactant.
So when we're doing formula mass,
That
you
is
can
the
literally just
reactant
ignore
that
the
produces
numbers.
the smaller amount
The
of
only time
product.
that we have to look at those numbers is when we're doing the molar ratio. Otherwise, you can literally just ignore them.
That's
Yeah, because it's kind of confusing how we have.
Maybe it is. I think we're period.
Yeah.
You only have to do
You-
3 seconds.
I would go at least to the 7, that's 4 sig figs.
That's what she got.
But no, you don't have to write all of that, nope, not at all.
Can I go to the bathroom? Thank you.
Are you sick, Alexis?
Yes, I'm very sick.
Are you tired?
So then
Yes.
do the molar
Okay,
ratio
they
for
always
that
go
one.
together, so.
So it's gonna be
What's that
different on
mean?
the first one,
Have you ever had
Because
anybody people go
we're
out
starting
sick
with
and
this
tired?
the
They always go
2HCl,
together.
and we're going to the SO2.
So you gotta.
So then what we're going into is gonna go on the
And you'll be
top.
fine.
So if you say you're sick, but you're not tired, you're probably not
Over
sick.
2 moles of the
Oh,
HCl.
that's why you sleep when you're
And so then we have
sick.
to multiply that.
That
So you
makes
just got
sense.
that.
Testing me? I don't understand.
Or you just ignore it when you're sick.
Yeah.
Or you can just divide by 2,
I
yeah.
I just slept the whole day. Second floor bathroom.
Okay. So what number did you get? Yep, okay, so
Like,
then
we
we're
gotta
going to
start
that.
out.
This is the only thing that's different, right? You have to figure out
So you're
which one's
gonna-
bad, so which one you have less.
So we put the smaller one into
Yep.
the.
So then what you wanna do is identify that as the limiting reactant. So like the number
One
here,
mole on
just
the
draw an
bottom.
arrow and label it as LR.
This
Otherwise
is
you
what
will
you're
be
going
close
to, so
that.
that's 1 mole on top.
Well, I already multiplied this one, but yeah, so you
So then-
multiply these top two.
Now that you have that,
multiply it
You know
by
the last
one,
step where you have to get it into
that.
the final unit. So like for this
Yes.
one, it's asking for liters of sulfur dioxide. So you
Well,
use that number, the smaller one, and you get that into the final unit.
You don't have to do
And so
this
then you
step.
do that using the PV.
The reason we don't do
That's
this
why it
step,
gave us
we
that
already
pressure and that temperature.
we're doing limiting reactants now. What that means is, there's nothing wrong with what you've done here, but number one, it never asked for grams of this. So there's no reason to put it into grams. Down here, when you're putting it into PV equals nRT, that is fine, but the one thing you have to check, we're stopping now after our ratio step to see how much product of this stuff we can create in moles. And the reason we're stopping there is now I need to take this 10.6 grams of HCl, and I need to figure out how many moles of this
Or
stuff we're
430.
creating. Because in a reaction, you're gonna run out of something. And as soon as you run out of something, your reaction stops, okay? And when your reaction stops, whichever one you ran out of, that's what we call the limiting reaction.
Is this McCarthy gonna be
I'm
there?
gonna show you it up here in a minute. So the good news is what you've done here is fine. The only reason I'm saying you didn't need to do this is because it wasn't asking for grams of this. It was asking you to put it into this formula,
Really?
but the only thing is, if this isn't the smaller one, that's not the number we would use there.
Literally about to
And
shut
I'll
off.
show you that in 1 second, okay?
Who's gonna be good?
All right, ladies and gentlemen, give me your attention. Give me your. Take a look up here, ladies, gentlemen. Please. Here's your balanced equation. Here is what you are given. You are given 145 milliliters of 0.957 molar sodium sulfite. You are given 10.6 grams of hydrochloric acid. We are asked to find, and this is a typo, this should say liters of SO2 gas at 1.11 atmosphere and 35.6 degrees Celsius. We take what we're given, we get it into moles. Now, again, if you need to write this down somewhere, volume times molarity equals moles. So I'm always going to give you a volume and a molarity if I'm giving you a solution. And all you have to do to get it into moles is multiply the two of them together, but remembering that your milliliters needs to be in liters. If they gave it to you in liters, you wouldn't have to do anything to it. Your volume in liters times your molarity equals the moles of that substance.
And it goes vice versa too, the molarity times the volume, or molarity times, or mole times molarity flipped equals volume?
It does.
If I have like the molarity and I have
So-
the liters on top over the mole, that would give us the volume again?
So if you have
Like
moles
yeah. Mole.
times a molarity, say 3.11 molar,
Mhm.
you're going to end up putting, yes, this actually is this. That's what molarity is. That's what it means,
And
okay?
then to solve for liters, we would just flip it.
We would flip it. Because we're treating it as a conversion factor, we would just flip it, okay? So again, what it amounts to is this really means this. 3.11 moles equals 1 liter. Glad we're doing math now since Ms. Firk is here. Okay? So we can put this way, or you are absolutely correct, KP. We can flip it over. Now, what I'm telling you is that right now, when we go into a problem like this, I have to give it to you this way. I have to give you a volume, and I have to give you a molarity, and we simply multiply the two together. Because the first step of any problem is to do what?
Take what you're given and put it in the bowl.
And that's what we're doing here. Now we're doing the same thing here. But we, instead of being given molarity, we are given a mass. So we are going to do how we go from mass to moles. Now again, that was unit 5. Unit 5, we had that mole in the center. We had volume up above. We had particles on one side. And we had mass on the other. Okay? Here's the fact. We're done with this part. I am not going to again. Hey, I know Cynthia's exciting. I know she's here.
Who wasn't even looking at her?
Okay? But stay a little focused with me, please. We're not going to do the particles part anymore. We're not going to ask you how many atoms there are in this sample. We're just not. We did that. We've been through that. It's not a practical way to measure things in the lab. Measuring mass is. Measuring molarity and volume is. Measuring the volume of a gas is a practical way we can give you information in the lab. Okay? So, these two parts we're not doing anymore. Why? Because our gases probably aren't at STP. So we can't use that 22.4. But this part over here, ladies and gentlemen, this is formula mass equal to 1 mole. And some of you are forgetting that one. That is how we always get from mass into moles, is with formula mass. Now, how do you know what formula? Well, it tells you what the substance is. 10.6 grams of HCl. Okay? So now we do 1 mole over the formula mass, 36.46 grams per mole. Okay, taking what we've given, got it into moles. Second step is always what?
Molar ratio.
Molar ratio. You'll notice our molar ratio, same thing on both of these on the top. Why? Because we're only going to one product.
That's not the same thing. On the top.
1 mole of
no.
SO2 and 1 mole of SO2 is not the same thing?
Yes.
It's okay.
Are you gonna ever have us going into different ones where
No.
it's not gonna be the same thing on the
No.
top? Oh, okay.
Well, because here's the
It's
thing.
just the way you worded it.
Let me explain.
Okay.
If I asked you to find out how much water and how much of this, you would have to do 2 different calculations.
Mhm.
And if we're trying to figure out which one we make the least of here, and that's what we're trying to do, you can't do it if you're comparing 2 different things in your reaction. You have to compare to the same thing. So in our problems, I will tell you right now, you're only going to be finding something out about one of the products. Okay? One of the products, just like we're doing here. So we get through the ratio. Again, our tops are the same here, but our bottoms are not. And the reason the bottoms are not is because there's different numbers in front over here. So when we're going from HCl, we need 2 moles of HCl on the bottom, 1 mole of SO2 on top. When we're going from Na2SO3, sodium sulfite, we need 1 mole on the bottom and 1 mole on the top. And just a minute ago, Sophia said, well, wait a minute, I get the same number of moles for this as I do here. Yeah, because it's a 1-to-1 ratio. It's a 1-to-1 ratio. You're going to do that. Here, this is half of what the moles of this would have been because it's a 1-to-2 ratio. Okay? Questions on this part?
Why'd you put PVN?
Because we're getting to that, which is to take and put this answer into volume of a gas. This is the formula we're going to have to use. Okay? But we're not quite there yet. Okay? The reason we're not quite there is because we make these two amounts of product of SO2. Well, in a chemical reaction, you can't make two different amounts of something. As soon as you run out of something, the reaction stops. It's done. Think back to our gas law lab. As soon as that magnesium in the bottom of your gas collecting tube was gone, the reaction stopped. There was still acid in your tube, but without the magnesium, it doesn't have anything to react with.
So then, what is this, like, what is the limiting reaction, like, showing us? Because I know we get two different amounts. Does that mean that one makes that amount and then the other makes that amount?
Yes,
But,
exactly.
like,
If,
in total, they make, like,
no,
I'm confused.
just slow down. You were doing good there, but hold on. If you have this amount of this stuff, which is what we start with, this is how much product you can make. Okay? Totally ignoring this. If this is there and this is the one that we run out of, we run out when we make this amount. Stops. Okay?
But aren't they, but in the problem, they're reacting together. So
Correct.
how does that work?
Well, now we look at this one.
Mm-hmm.
This one says, you know what, I could make this amount. Okay? So which one is smaller?
The top one.
The top one, obviously, right?
Oh, so that's
So
the
guess
one
what?
that's gonna-
This reaction stops once you make this amount. Now, there's still some hydrochloric acid left there.
Okay.
Why? Because we didn't use it all up.
That makes sense.
So just like one is limiting, one is always in excess. Some of it's still hanging around. Okay? But since there's nothing for it to react with, guess what? Can't do anything. It's done. The reaction is ended. Questions? This is why we have to get to the same thing. We have to compare product to product. Why? If we picked a different part of the reaction, this ratio would change or could change. So again, we stop when we're here. Now, Cynthia, third step of our problem. 1, take what you're given, get it into moles. 2, use a molar ratio. 3, report out in your final unit. The unit that it asked was for volume of a gas under these conditions. Okay? So now I have to use PV equals nRT. What would I use if it was a gas at STP?
22.4.
We'd use 22.4. It'd be easy. Take this times 22.4 liters over 1 mole. Boom, we'd be done.
Wait, so are you going to do it all together, or are you going to plug in two different equations to get two different answers?
I don't need to plug this one in. Think about this.
So you're using the smallest one?
Thank you.
Oh, okay.
If I use this, this is the amount of this I get, correct? What would happen, now show off in front of a former math teacher. What would happen if we put in a bigger number here?
And the smaller answer?
This number would get,
Bigger.
we were so close. If
Yeah,
this
you
number
gave it
is
a shot.
bigger, you gave it a shot. Thank you, Cynthia. You weren't afraid to give it a shot. If this number gets bigger, guess what? This number is going to get bigger. And since we can only make the smaller amount, we'd go back and say this is all we could have made anyway.
But
Okay.
it's asking milliliters.
I know. Sorry you missed that.
He corrected.
I changed it because when I got to this point, as it's been happening with my problems lately, when I did my calculation, I realized, would you put this number into milliliters?
Nope.
No, it doesn't make sense. You would make it 3,170. We would leave it as liters.
Oh.
Okay? We would leave it as liters.
You would.
Go
So
ahead.
that wouldn't say ML, that would just say.
Correct. The original problem, which I had up before you got here, it said liters. Okay. I just didn't take that out because this is a photo of my work that I did on this morning. Okay. My bad. My mistake.
Shake my head, do better.
I know. I should. I'm trying. Okay. Questions?
Now,
Okay. Here's the thing that scares me though, ladies and gentlemen. You say no, but the look in your eye doesn't say no.
What does the look in my eye tell you?
Yours says, okay, I kind of got this.
Oh, okay.
Okay, but there's some who are not looking at me, who are looking down because they don't want to make eye contact, because they're afraid that I'll read into their soul and go, ooh, you're still struggling. What?
Limiting reaction.
This is called stoichiometry with a limiting reactant. Okay? Now, again, what? No.
What's that quiz?
It's on
Good
the
question. This part without doing this,
That's it.
or this part without doing that. In other words, I'm going to tell you one's in excess. We're going to tell you which one is limiting. Okay?
It's just this, but you only have to solve for the one.
Correct.
You don't have
You
to
only
do
have to do
twice.
the work. If you know that one of them is in excess, it means the other one is guaranteed to be limiting. And then you don't have to do the calculation twice, because we know which one we're going to run out of. The one that's not in excess. In excess means we got too much of it.
whoever
Okay.
says that,
We have access to
She's
something.
gonna give us
We
the
just
one
find
that
that
one.
Yes.
Oh.
It's what we were doing before this, like where it was just like, oh, how
Yeah.
many grams of blah blah are produced in this reaction.
So all we're doing in reality is like two problems at once here. We're doing it based on this amount of this stuff and this amount of this. Now I don't know which one I'm going to run out of first. I got to figure that out. Once I figure that out, actually, this one I did, but it doesn't matter. Why? Because there's more of this at the end. Okay, there's more of this at the end. So this is what I run out of. This is what I put into here. Now, again, what happens if these work out to be the exact same?
You can use anyone.
It's the same amount. Put it in here. But what does that mean for your limiting reactant?
But it's both.
That it actually is both. You could have a reaction where you run out of things at exactly the same time.
Are you gonna give
They
us
avoid-
that?
No. See, that would be the perfect world. And our world isn't perfect, which is why they sell hot dogs in packages of 8, or buns in packages of 8, and hot dogs in packages of
What does that have to do?
10. Well, okay, which one's in excess?
10.
The 10 hot dogs are in excess because you run out of the buns first.
That's why you buy 2 bags of buns.
Then what's limiting?
Hot
If you buy
dogs.
2 things of buns and you have 16 buns and only 10 hot dogs, guess what? One of them is still limiting.
Just buy 80 of each. And you'll be.
Go down to 40.
Good plan. And call me over for dinner that night because I like hot dogs. Okay?
But the whole
That was good math. I'm glad you went to 80 of each because it really showed off in front of our former math teacher. That's
I
a good
just
job.
multiplied them together.
Yeah, and we could have cut it in half too and done 40, but it's okay. We're all
I
right.
wanted to invite the whole track team.
Okay.
Sorry, I did 81
You
for
like
you.
hot dogs?
Yes. Why? What's wrong with hot dogs?
They're so, this
I don't know,
smell
whenever
is
I
so
think of hot dogs,
disgusting.
Real. That is a baseball thing.
Look at this body. Does this body not look like it's ate a hot dog in its life? Come on. Come on. Okay. Questions?
Really? They're so fun. If they're actually good. Don't go to these ones.
Okay. Now's your chance, ladies and gentlemen. You have got practice problems in your notes to start, or in your packet to start working on. Again, questions, call me over. Here's the one thing I will tell you. If you're working alone, you better make sure you kind of know what you're doing. If not, get with somebody. I don't care if you guys go get in a group of 12 at the back table and work together on it. I would rather have that than you sit there and be like, well, I don't know what I'm doing. You could actually learn from each other.
KP, you wanted to teach, you wanna take over now?
Yep, let me do it. Let me be the teacher.
Okay, I'm going to sit down.
Okay.
I think
Let
baseball's
me
my favorite sport.
If anyone needs help,
So
call Mr.
American.
Perez over. I'll be right there.
I feel like such an American when I watch baseball.
What?
Man, why does it
Me and Cynthia.
Baseball's so American.
What do you mean they don't make
I was
sense?
asking one this morning, and like, it just didn't make sense.
Baseball or soccer?
Take it out, let's take a look at it.
No, I figured it out.
She doesn't need your help, Mr. Perez.
Yeah, no, I like to.
You know what?
Yeah.
That's a sign of a distinguished educator. When you no longer need me. Thank you for
As
saying
far as I
that,
know,
but this
they
time I'll
still
give you the
do
$5
it.
savings.
Or I go,
UWG.
No, literally, because our backs are curved. Our backs are turned. No, we're not gonna win.
First of all, you're guaranteed to get into UWG because you're
I
ready to be
just
successful. Where are you thinking?
Oh, okay. So I was gonna say for.
What are you going
we're not
for?
allowed to have it. Yeah, we get.
I know, it's just
And that would make her school. You realize there's not a lot of wording in biology in Wisconsin. Well, at least you thought that. That's important.
That's why. Last year.
Yeah, that's the only
What It was what happened.
Sir.
Yeah, it was sunny.
Yeah, but that's our wait.
Here, I want you to know this.
Because it's mine, it's hardly used.
What is roommates?
Which one? This one?
What
On
about?
the back of your periodic table, ATE ending.
I haven't.
Limited reagents? Is that not this one?
Reagent and reactant mean the same thing.
Oh, okay.
But I went up to her and I was
Two
like,
different
"This is
terms that
what
mean the
happens
same
when
thing.
you're doing a sandwich." And she was like, "Okay."
Since we've been on the topic, I'd like saying hot dog versus a wiener.
And she was like, "You know, there's
Same
something for her."
It's
And so I'm like, "You have a hot dog here."
I know.
I was like, "Yeah, you did." I was like,
I got 30 minutes till lunch.
Like the was that one?
What do you mean?
No.
250
No, I actually have.
If it's aqueous, it is a solution.
But like, can you come here? I just don't know what I just did.
Hang on, let me take care of our.
"Oh, that makes sense." That's all. She's just so good.
Why are you doing this?
I just don't really care. I just want someone to myself.
You know what I'm thinking about right now?
So
I
you just,
wish-
you're just randomly picking two elements and putting them together.
I wish
So
they were
correct.
good because
So
then I don't
correct.
have to sit through like 2 hours.
Means that it is not binary.
Like every day.
That means it involves a polyatomic.
That's
Yeah.
And an acid comes from an polyatomic combined with hydrogen.
She was sitting there.
So sulfuric would come from sulfate combined with hydrogen. Sulfate, combine it with hydrogen. You need to start writing this down somewhere.
I was waiting there to take her back to her room, and I was like,
You
"Oh, I
can't
can take
just
her now."
guess, it will not give you that answer on a test.
Because I didn't have practice.
Okay, I'm sorry.
Wait, yeah.
I don't know. It's like maybe
Which one am I?
I have a game today, but it's only a varsity game. So James says
Okay.
not gonna play.
So
I know for
now,
a fact
if
he's
you've
not
got 20
playing.
grams and
She actually
250
knows
milliliters, what can you
I saw her.
find?
She hydroxide.
He's only played one varsity game.
No. What are grams and milliliters going to give you?
He wasn't even a starter.
He's one of those
What if we
like,
said moles?
players
And
that can
there you go, find the molarity.
Yeah.
I'm giving it to you, maybe you calculate it first.
Why do we have to find the molarity?
Yeah, it's going to do.
Oh,
So I can't even
This
blame him.
solution, with this
Yeah, I can't even
solution,
blame him for being that.
50 milliliters of each of these. So once you find the molarity of this, here's how much you are combined, 50 milliliters. Now you can take the
Okay.
milliliters
Okay.
times the molarity to get the mole.
So I don't need a balance equation.
Well, yes, of course you can balance it out. Because eventually we're gonna have to do the math of the percentage. Now, instead of me giving you the molarities, I'm making you custom.
So then I do this, add to this, and I just switch them. Oh.
Yes, yes.
It's your man.
You should have taken. Next question, what?
Oh.
Oh, do you wanna take Cynthia's?
Is this
Is that a
right?
no? You don't like
I like working with
with
Cynthia.
Everyone likes working with
Okay, then why aren't you helping her help me?
You want me to help her?
What's your question?
This right there, right there, right? I don't know how to write. I get so confused on how to write. It's like,
Why would you put a 2 by now?
yeah. It's
She failed?
As an ion in a compound. Well, no, not whatever. Come on, this is the stuff I've been telling you guys already. An element alone, you just write its symbol. The only time you don't write it, just the symbol, is if it's one of the 7 diatomics.
and it would get to here.
Correct, yes. That's why I had to tell you that it's a +2 ion. You can't look up there and find its charge.
I know.
So in the compound, now you need to know that it's a +2, yes.
Okay, so this is written right.
Oh.
Yes.
Yeah, I guess.
It's only the metal switch, right? When it's a single replacement. When it's a double replacement.
The metals still switch, but they're both with something.
Just hydrogen? Mr. Ray, you done taking the labs?
What?
Are you done taking the labs?
What do you mean, done taking the labs?
Because I had a lab.
So she must be slow and not
So why did you turn it in?
I was asking her.
That's crazy.
Well, you'll still get some credit for it.
It's on the back of your PRX table.
People are funny.
Okay.
Oh. That's
Right,
one
Mr.
that we had to highlight.
I
It's
agree.
like,
I agree 150%.
Oh, that's a lot.
Oh, yeah. Okay, thanks.
I always go the extra mile.
Okay.
Oh, yeah.
Oh, yeah, yeah. There's literally a star next to mine, too. I don't know why.
Here's the thing. That degree sheet
Literally,
is always what you're trying to find over what you're in. So that's the one that has to go on the top of what you're in. 10 grams of sodium chloride. So that's what's on the bottom. Always what you are in is on the bottom and what you're going to is on the top. Always.
I told my
Always. Question.
told me that the CNA was over in Monterey was complaining about the other clinical group when they and she was
Oh, okay, sorry.
I was like, dang, I was like, something I really feel like, because she was so like, and then yesterday we had 2 of the girls from our clinical group.
Thank you.
Or no, we had 2 girls from our
Think
clinical
some
group
girls.
with us, right?
I'm not worried about me. I'm more worried about someone else.
Sorry. Phoebe's sick. Like everyone around her sick.
why is Phoebe sick?
But they're like best
You're
friends.
not around.
She's
Not here, you're here. Oh,
Yeah, because they're best friends. Mr. Man. Catch on.
I never noticed. Sorry.
Really? You've never noticed that they're best friends? I feel like it's so obvious.
Okay.
No, I'm actually
Up
not.
to you. You want to do it because they still do it the same way.
I think she has.
So,
Dude, I have
now,
to
here's a trick you
into a
could do.
full on
If you
full
separate.
It'd be so mega
Oxygen is
And then
in
I'm
every one of these
stomach started
compounds,
hurting really
right?
bad, and I've got like a really bad migraine. So it's like it was all like
Oh my god, I woke up
Okay, in other words, you don't have to count it up.
really wrong.
You can treat it like because if something is in every single compound, at the end, it has to be balanced. Because there's no way to balance it without messing everything else up. So you can ignore it. So again, you could still put NO3 and OH on the bottom.
Too much
Or you could
metal.
put
Too
the
much metal.
NaOH and ignore the oxygen. Either way. Okay? And, okay, that's what I
Oh
mean.
my god.
Balance it out doing that, and it becomes a little bit easier for you, because here's the thing, every time you put in a number up above, you're gonna have to recount those oxygens, and that's a good chance.
Oh, you're gonna
That's why I say just ignore it and balance everything else,
Just don't laugh.
and at the end it'll have to be balanced.
Just don't.
Okay?
Just don't laugh.
Like,
Oh,
I think you too, because
Oh my
no.
goodness. I thought I was thinking, oh,
Okay.
God, but
It says, I have to get into moles, right?
Okay, how do you get from grams to moles?
literally.
Yesterday I walked up.
This is not one.
That's so funny.
Yeah, but what if buffer's not by itself?
I'm doing
Unless
limiting
we
reactor
find
ones.
the massive problem.
It's the same thing as what we're doing tomorrow.
You can compare any two parts of a reaction that you want.
What time is it?
Okay.
7 o'clock.
So what I mean by that, Cynthia, normally you're going to compare a reactant to a product. But you could compare a reactant to the other reactant. It doesn't matter where they are. Okay? It doesn't matter where they are.
Can I go to?
Can I go bathroom?
Okay, now that I understand what you're asking, yes.
Thanks.
Sorry, I don't speak French.
If I have a
French?
molarity under like 1, like if it's 0.52.
Why? Because all of it comes back to molar ratios. Now, part that's hard to understand. This molarity, this would be in a certain amount of solution, correct?
Yeah.
Well, when it breaks apart into these, how much solution is it in? It's still in the same amount of solution, correct? But now because this doubles, the molarity doubles, right? What you've just done is calculated the concentration of ions in a compound. But the concentration of ions in a compound is just like a balanced chemical equation. In other words, if this is a 1-to-1 ratio, however many moles of this you have, that's how many moles of this you're going to have. And if this is a 2-to-1, this would double. What if there was a 3 in front of here? What would it have been? 3.45. Those ratios make life so much easier for us. Okay? Now, granted, if we had 1 mole of this, that would be sweet, because then how much of this would we have? 2 and then 1, right? But we normally don't have a mole. Normally we have part of a mole or more than a mole or something like that. Well, once you know how many moles, we can figure out how much would be on the other side. We can figure out how much would be on the other side. Okay? So, okay. Can't do that. Can't do that. Can't do that. Any idea why I can't do that? Well, let's do this.
Because it's aqueous. Oh, true. Wait, maybe.
What happens if we put this into water?
Splits apart. It precipitates.
So it wouldn't break.
Oh. So wait, so do they not get divorced? Oh.
If it's a precipitate, it will not break apart. It will not break apart if it's a precipitate.
Yeah, it's just there.
It's just going to stay there.
Just make it,
All right, let's do this.
make it like.
Here we go. Al, I don't want to do that. Al2, CrO4, 3. What happens to this when we put it into water? Into what? 2Al.
Plus 3. 2 plus 3 CrO4. Minus 3.
Correct? Okay. So if we have 0.776 moles of aluminum chromate, how many aluminum ions would we have?
Times 2. 1.5 times 2. You said it.
Right?
Yeah.
What about for chromate?
Oh my, how to cut
What do you say about So
Nope. 2 point. Yeah. 3. Yeah. You total 2.32.
Now we could put molarity as the unit, or we could put what? Moles. I said originally this would be moles, so okay. What if the molarity here was 0.125?
0.25.
It all comes down to these ratios, ladies and gentlemen. It all comes down to these ratios. Now, here's what I'm going to tell you, ladies and gentlemen. I will not put a problem like this on your test. At least not worth points.
Extra credit.
So,
Extra credit would be better.
no, extra credit would not be worth points because extra credit would be bonus. So you can't technically lose points on an extra credit problem. I wouldn't put this anywhere on a test where you could lose points on it. Let's put it that way.
Because I mean, technically, extra credit is worth points. Right?
Okay. But it doesn't hurt you if you get it wrong. So maybe I phrased it incorrectly. I should have phrased it
Worth points. If something's worth money or lose money.
All right.